Good morning. It's December 29th, and this is your daily brief in science. Here's everything you need to know. A quiet year for UK quakes turned into a steady drumbeat of tremors across 2025, with more than 300 earthquakes and 1,320 public felt reports by December, showing frequent small quakes rather than big ones. The British Geological Survey emphasizes that studying these events helps gauge potential impacts on energy infrastructure and how authorities can reduce seismic risks to buildings and networks. Two of the largest onshore quakes occurred near Loch Leon in Perth and Kinross within hours of each other on October 20, magnitude 3.7 and 3.6, both widely felt in the area. Historically, magnitude 4 events happen about every 3 to 4 years, magnitude 5 every few decades, the last in 2008 in Lancashire, and magnitude 6 events only every few hundred years in the UK. BGS data show magnitudes clustering at these ranges, with 4 around every 3 to 4 years, 5 every few decades, and 6 every few centuries, punctuated by rare 5 to 6 events. Even when many quakes are small, the UK experiences rare magnitude 5 events every few decades and magnitude 6 events roughly every few hundred years. The 1931 Dogger Bank earthquake remains the strongest on record at magnitude 6.1, and 2025 contributed to a year with felt quakes across Great Britain. Residents reported vivid tremors, with ground shaking and windows rattling, underscoring that modest quakes can be widely felt. Seismologists say UK earthquakes stem from fault activity and regional deformation, with the west of Scotland especially active due to faults like the Great Glen Fault and the Highland Boundary Fault. Around 80 seismic stations monitor the UK, with Perth and Kinross standing out in 2025 due to local fault systems, while northeast Scotland recorded fewer events. The mechanism is straightforward. Small earthquakes occur when stressed rocks along faults release energy as seismic waves, producing surface shaking. A rural fight against desertification is underway in Hungary's semi-arid Homokatszag, where a farming group led by Oskar Nagyapati floods low-lying fields with cooled, purified thermal spa water to restore groundwater and land moisture. The effort began as a pilot and has grown into a volunteer-driven movement with more than 30 helpers, aiming to expand to additional flooded fields. The team redirects deep underground thermal water from a local spa to a 2.5-hectare plot after negotiations with authorities and temporary canal sluice closures. By blocking sluices, water collects to form a shallow marsh within a 4-kilometer radius, a change researchers associate with groundwater improvements and a boost to local biodiversity. The project seeks to raise groundwater levels, create a microclimate with higher humidity, reduce dust, and support nearby vegetation through this water retention strategy. Experts stress that retaining water and managing microclimates are crucial for regional climate resilience amid drought, and describe the project as a potential model for others. Authorities have expressed support, and there is interest in expanding flooded areas to extend the water retention benefits. Meteorologist Tomas Toth and other experts underscore water retention as essential for mitigating climate variability and future resilience. Nagyapati points to returning water to the landscape and ending water loss through natural recharge. The effort aligns with Hungary's drought response, including a government drought task force addressing persistent water shortages and agricultural impacts. The movement's plan includes extending to another flooded field and encouraging broader water conservation across neighboring villages and towns. A company is extending a share lockup for insiders to align with long-term investors as it pushes the Flamingo-01 Phase 3 trial of GLSI-100, an immunotherapy aimed at reducing breast cancer recurrences. Flamingo-01 is an open-label, Phase 3 trial led by Baylor College of Medicine, evaluating GLSI-100, GP2, plus GM-CSF in HER2 positive patients with residual disease or high risk after standard therapy, planning to enroll up to 150 sites globally and randomize about 500 HLA-A*0 patients to GLSI-100 versus placebo, plus additional patients with other HLA types. GLSI-100 targets the HER2 protein to prevent recurrences and sits within broader breast cancer statistics and HER2 positivity prevalence. The market reacted positively, with GLSI stock rising about 5.25% on the news and trading volume roughly 2.9 times the 20-day average as the price hovered near $21.77. The press release includes forward-looking statements and cautions that results are preliminary and subject to risks disclosed in SEC filings, with investor relations and PR contact details provided. Standard forward-looking statements and risk disclosures are included, with specifics in Greenwich Life Sciences-2024, Form 10-K and other SEC filings. The release provides investor and public relations contacts alongside the usual forward-looking statements and risk disclosures. Historical updates on trial progress and strategic funding are noted, with the lockup extension fitting a pattern of governance moves tied to long-term trial development. Share lockup for directors, officers, and pre-IPO investors has been extended to September 30, 2026, with potential for earlier termination or alternative sale mechanisms such as leak-out plans or 10b5-1 trading plans. Board-controlled extension affects remaining locked shares through 2026, reflecting governance decisions around share release. Management indicated the board may end the 100% lockup earlier and implement staged sale options or other mechanisms. Interim and open-label Flamingo-01 data show preliminary signals of strong immune responses and a notable reduction in recurrence, including about an 80% decrease in non-HLA-A*0 arms after the PIS, with similar trends to Phase 2b results, though data are preliminary. A new comprehensive review links varying levels of alcohol use to cancer risk in U.S. adults, examining how associated comorbidities and social determinants shape outcomes. Drawing from 62 studies, the analysis finds strong associations with higher risk for breast, colorectal, liver, oral, laryngeal, esophageal, and gastric cancers, with particularly poorer outcomes for liver cancer related to alcoholic liver disease. Risk factors such as race and ethnicity, age, socioeconomic status, obesity, alcoholic liver disease, and diabetes influence alcohol-related cancer risk and contribute to disparities in outcomes. Limitations include exclusion of case reports, letters, abstracts, and gray literature, and potential omissions from reference tracing, which may affect comprehensiveness. The article notes publication in Cancer Epidemiology on November 13, 2025, with study authors, DOI, and affiliations listed. Following American Cancer Society guidelines and broader healthy lifestyle changes are associated with lower cancer risk and mortality, highlighting moderation plus overall lifestyle improvements. Policy and prevention implications call for integrated strategies that combine lifestyle interventions, policy measures, improved access to screening, and early detection to reduce alcohol-associated cancer risk. Despite alcohol's Group 1 carcinogen status, public health messaging and labeling often do not stress cancer risk, revealing a policy gap in consumer communication. The review includes 45 cohort studies, 13 case control studies, 2 ecological studies, 1 quasi-experimental study, and 1 cross-sectional study, with participant numbers ranging from tens of thousands to nearly 100 million. Targeted public health actions are recommended, including tailored messaging, stronger alcohol-related policies, and interventions aimed at high-risk communities to reduce the cancer burden. There is no universally safe level of alcohol for cancer risk, prompting questions about warnings, routine screening for alcohol use, and better public health information. Biological mechanisms discussed include acetaldehyde-induced DNA damage, hormonal changes, oxidative stress, immune suppression, and increased carcinogen absorption, interacting with health conditions and genetics to drive cancer development. Scientists have unveiled KaBlam, a bioluminescent imaging system that lets researchers monitor neural activity at single-cell and subcellular levels without external illumination. Bioluminescence offers higher contrast signals in tissue because it avoids external light, reduces photobleaching and phototoxicity, and lessens scattering and background noise compared with fluorescence. The system uses a bioluminescent calcium sensor designed by Nathan Shaner and colleagues, enabling neurons to emit light that tracks calcium activity for multi-hour recordings. This is a multi-institution collaboration involving at least 34 scientists from Brown University, Central Michigan University, University of California, San Diego, University of California, Los Angeles, New York University, and other institutions, supported by National Institutes of Health, National Science Foundation, and the Paul G. Allen Family Foundation. The effort reflects a broad push to advance bioluminescence tools in neuroscience and beyond, with the Bioluminescence Hub at Brown's Kearney Institute playing a coordinating role since 2017. CABLAM can observe activity within different parts of a neuron and could support studying brain processes during complex behaviors or learning with fewer hardware requirements. Beyond neuroscience, CABLAM and related calcium sensing tools may be used to study activity in other body tissues, expanding potential biomedical applications. The study demonstrates continuous 5-hour recordings in living mice and zebrafish, capturing activity across neuronal networks and subcellular regions in real time. The work is documented in Nature Methods under the title CABLAM, a high-contrast bioluminescent Ca2+ indicator derived from engineered luciferase with funding from National Institutes of Health, National Science Foundation, and the Paul G. Allen Family Foundation. CABLAM enables recording from individual neurons for hours and within subcellular compartments, opening new avenues for research on learning, behavior, and brain-body communication. Nathan Shaner led the molecular design, with Chris Moore highlighting CABLAM's potential to visualize single-cell activity like a high-sensitivity movie and to observe activity inside living animals over extended periods. The Bioluminescence Hub at Brown University's Kearney Institute supports a community of researchers developing light-emitting neural tools and sharing them with the broader field. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.